Hello everyone. Today we're going to go over the least common multiple, which is different from the greatest common factor. The greatest common factor usually tends to be a number smaller than the numbers we're given, whereas the least common multiple is usually a number that is bigger than the set of numbers we're given. So let's go ahead and look at the methods we're going to go over on how to find the least common multiple. So let's look at the definition first. We have the least common multiple is, for short, LCM. Is the smallest positive number that is a multiple of two or more numbers. So we're going to go over our first method called the list method. Usually this is a pretty easy method to use when your LCM is a smaller number. So what you would do is first you would write out the multiples of the numbers. So like pretty much what's on the multiplication chart. So like the 2's would be 2, 4, 6, 8, 10, and so on. And second, we would find the smallest multiple in common. So if we're looking at the LCM for the number 2 and 4, which are here, we would see that the multiples of 2 are 2, 4, 6, 8, 10, 12, and it keeps going forever, versus 8, which is 8, 16, 24, and so on. So we can see that our common multiples would be 8, 16, and 24 just based on this list alone. Again, if we extended our list of 2, we would have more common multiples. But the least common multiple would be just picking the smallest one. So in this case, my LCM would be 8. 16 and 24 are just regular common multiples, but I want the smallest one. So that's how we work with the list method. Just make a list and look for that common multiple. But again, this is not the favorite method in terms of having a larger LCM, because then you're going to be writing numbers for a long time, especially if it's in the 3 or 400s. List method is good for small LCMs. You don't always know if it's going to be a small number or large number, but that's kind of how it works, but it is a fairly easy method. All right, our second method would be using factor trees, just like we use with the GCF. I would say doing the LCM with factor trees tends to be a little bit more difficult for most students, because then they end up confusing it with how to do the GCF with the factor trees. So I'm going to go over this example. So we first start off with our numbers 36 and 54. And from there, we want to list out the prime factorization, so pretty much make the factor trees. So we have a factor tree for the first one and a factor tree for the second one. And what we do is to get the LCM, we don't circle what's in common on each tree, and then that's my GCF. But for the LCM, it's a little different. You multiply the highest number of times each factor appears in any of the given numbers. So to make that a little easier, I went ahead and wrote out the factors here. So again, the 3232 is right here. So this 3232 is right here. I just put them in numerical order. And the 3233, which is for the 54, I wrote it out as well, just in numerical order. So again, we multiply the highest number of times each factor appears in any of the given trees. So because we're talking about multiples, we want to see where they're going to be common as we're multiplying out the number from the multiplication chart, thinking of the list method. So I'm going to look at the first one. I see the 2 shows up twice, and on the second one, the 2 shows up once. So I'm going to choose the one that has the highest number of times where this number appears. So I'm going to be taking the 2 times 2, because there's 2 2's here. Think about this 2 down here already represented in one of the 2's on the top. For the 3's, I have 2 3's and 3 3's. The highest amount would be the one at the bottom. So we take these right here. So my LCM would be, again, from either of the 2 prime factorizations, I take the numbers where it shows up the most times. So in this case, it would be 2 times 2, and 3 shows up 3 times the most in one of the trees. And if we multiply this out, we get 108. Now, if you still need more examples, go ahead and go to Canvas, Module 3, look for the section Additional Resources, and there's more videos on how to find prime factorization and the LCM through prime factorization. So again, there's more examples there if you want to see more, but again, I'm going to focus on the third method, which is the ladder method. So we look at that method. It's like the one we learned yesterday. The only difference is instead of finding our GCF by just multiplying the numbers here on the side, the LCM is multiplying all the numbers around, making an L shape. Think of L for the word least. for least common multiple. So that's the difference in the LCM in the ladder method versus the GCF, which was just these right here. So GCF is these, LCM is all the way around here. So let's go ahead and do the ladder method for these examples. So I'm going to do the ladder method and probably method 1 as well for some of these examples. So I'm going to go ahead and say starting with number 1. So I'm going to do method 1, doing the list method. So for number 8, I'm going to go ahead and put 8. And the multiples are 8, 16, 24, 32. I'm going to stop there. And it keeps going. And then I'm going to use 12. I'm going to do the multiples of 12. 12 times 1, 12 times 2 is 24. And I'm going to stop here because I already see a common multiple here. So 24. So I know that my LCM is 24. So this is using the list method. Again, luckily my LCM showed up pretty quickly. On number 2, it might not show up as quickly, so you would probably have to list more numbers. So I'm going to go ahead and do the ladder method for number 1 as well. So I'm going to do 8 and 12. Works out the same way as yesterday. So factor between 8 and 12 would be 4, which gives me 2. 12 divided by 4 is 3. And using the ladder method, I cannot go any further because 2 and 3 are prime. So for the ladder method, again, my GCF would be, my LCM would be me taking these numbers and multiplying them, which would be 4 times 2, which is 8, and then multiplied by 3. So it would be 8 times 3, which would also give me an LCM of 24. So again, both methods work. You can also use the prime factorization with the factor trees, but again, that one gets a little confusing if you try to count the number of factors. Again, if you want to do it that way, feel free to look at the videos on that are in the additional resources. All right, let's go ahead and do number 2. I'm going to just do ladder method for the rest of these. Feel free to do any of the other methods on your own on these notes if you prefer. Just double check that your answers come out the same. All right, 60 and 72. These are both multiples of, again, depending on how you see it, you can probably say 6. So 6 times 10 is 60. 6 times 12 is 72. Then we're going to look at 10 and 12. Is there another common factor? Yes. These are factors of 2 because they're even. So 2 times 5 is 10. 2 times 6 is 12. Now 5 is prime, so we're done with our ladder method. Now we're just going to look at our LCM, which is that L shape. So it would be these numbers. We're going to multiply these numbers for the LCM. So my LCM is 6 times 2 times 5 times 6. 6 times 2 is 12. 5 times 6 is 30. And if I multiply these numbers together, I can just do 12 times 3. That's a little easier to do in your head, and then just add the 0 at the end. So 360 is my LCM. So again, if you had done the list method, you would have had to list the multiples of 60 and 72 up until you hit that 360. Probably would have taken a quick minute to do that. So let's go ahead and move on to the next one. All right, here we go with number 3. So we have another set of numbers. These have variables, but don't be afraid, it's the same idea. So we're going to have 20, x6, y, 45, x5, y, 2. All right, we're going to go ahead and draw our ladder. So what's a common factor between 20 and 45? Numbers that end in 0 and 5 have a GCF, have a common factor of 5. We're going to go ahead and divide by 5. That's 4. Just put our variables down. Let's ignore the variables for now. We'll take care of them at the end. We're going to go ahead and do the next ladder. Now 4 and 9 actually have no numbers in common. So 4 only divides by 2, and that does not go into 9. So we're going to move on now to our variables. So we're going to factor out what they have in common. So if I have 6 y's and I have 5 y's, what's the equal amount I can take from both sides? So I can take 1 from each of these. I can take a second one from each of these. I can take a third one. I can take 4 here. I can take 5 here. But now I cannot take a 6th one from this side because this one only has 5 to give. So our GCF for these, what we're going to factor out is x5 because there's only 5 that they both have in common, which gives me 4x, because there's one left over, y. 9, all the x's were taken out, so there's none left for the second piece, so we have y squared. Now I'm going to do the y's. What's an equal amount of y's both sides can give? And there's only one on the left to give, so it's only going to be 1 in common. So we're left with 4x and 9. We took one of the two y's, and we have one left over. So now I'm going to go ahead and do my LCM, which is just multiplying all of this together. So let's take care of the numbers first. 5 times 4 times 9. 5 times 4 is 20. And I'm going to multiply that by 9. 2 times 9 is 18, so it's 180. So we're going to get 180 for our LCM. Now the variables, there's x5 here and another x there, so that's a total of 6 x's. So it's going to be x to the 6. And we have a single y here and another single y here. That's a total of 2 y's, so it's going to be y squared. So this is my LCM. Now, one quick way of thinking of the LCM for the variables, if this was confusing for you, like counting the y's, one quick way you can do this for future reference, I'm going to write this on the side. You can just do the numbers only, ignore it, and then just multiply them. So just do it without the variables, and that's still going to give you the 180. Now for the variables, you have x's and y's. For the common multiple, you have to pick the one that is the bigger one. So you pick the one that's bigger and you just put it on the side. So both ways will work. I think this is a little easier, but just have to remember one rule. For the LCM, you pick the one that has more on the exponent. So you just put the higher exponent. Actually, that's probably a better way to put it. You pick the variable, you put the number for the higher exponent. Unless you prefer to do it this way. So I'm going to go ahead and clear this out, and we'll work on number 4 now. Last example. All right, so we have the 3 numbers here, so it works the same way. There's only one quick thing we got to make sure we are taking care of when we're doing it with 3 variables. There's an extra piece that we did not do with the ladder method for the GCF. So we start off the same way. We look for a number that divides all 3 of them. I can see these are all divisible by 4. So 4 times 8 is 32. 4 times 20 is 80. 4 goes into 12 3 times, so it's going to be 30. Now I'm going to see what else divides these. These are all divisible by 2 because they're all even. So that's going to give me 4. 2 times 4 is 8. 2 times 10 is 20. 2 times 15 is 30. Now we go ahead and check what divides all of these numbers. So I know 4 only divides by 2. It goes into 10, but it does not go into 15. Now, this is an extra piece with just the LCM. This only works for the LCM, not for the GCF. If I was doing GCF, my answer would be 4 times 2 on the left. I'd be done. I would not do continue at this point for GCF. For LCM, we would actually keep on going if 2 of the numbers are divisible by something because of the common factor. So in this case, 4 and 10 have a common factor, which is 2. So I'm going to put 2 times 2 is 4. 2 times 5 is 10. Now for that 15, that one's just going to come down as it is. We're just going to bring it down. And then now you check 2 and 5. They have nothing else in common. They're prime now. But we should still realize that 5 and 15 have a common factor. So I'm going to keep on going. Again, you only do this for the LCM. So these are both divisible by 5, the 5 and the 15. So here the 2 stays 2. 5 divided by 5 is 1, and 5 into 15 is 3. And now I have prime numbers and the 1, so I'm done at this point. Now I can do my LCM. So for the LCM, I would multiply all these numbers here. So we're going to have 4 times 2. I'm going to write it here on the side because I wrote really big. 4 times 2 times 2 times 5 times 2 times 1. It doesn't really do anything. I'll write it in, but you don't have to. So 4 times 2 is 8. 2 times 5 is 10. 2 times 1 is still 2. Times 3 is 6. So we're going to multiply these together. 8 times 10 is 80. Times 6. 80 times 6 is 8 times 6 is 48. So my LCM equals 480. Now again, there's extra pieces here that I did right here at the bottom. one more time, this part right here, when I did this part right here, and I changed to blue, that I kept going, you would only do that for the LCM, not the GCF. So again, if you had stopped earlier and done your L shape, I'm going to do another color. If you had done your L shape here, this would have been wrong. This would just give you a common factor, but not the least common factor, and it would have been wrong. All right, so go ahead and start your IXLs in practice, and good luck.